Yep.
All right, so for everybody that's gonna either join or watch, the plan here is me and Michael, and if other people join the Hangout, we're not expert, myself, on my end. And the goal is kind of to just spend an hour a week just doing some messy coding. So, I mean, we could call them messy coding sessions, but we have some sort of idea, we go on Solidity with Truffle, and we try to make a contract that kind of has the feature that we're interested in for the day. And so feel free to put suggestions in the comment sections, or like definitely do not take my coding habit as something that is good. I need to improve them, and I think everybody would benefit from advices from other people. So today, what we wanted to do was kind of building a basic token contract with an extra tweak in it. So the idea was to make a contract that would have some sort of dividend component to it. And by that, I mean that the more you own, the more tokens you own for this particular contract, the more share you're going to receive, or the more valuable value you're going to get from the contract. So if I own 1,000 tokens from this contract at certain frequency, or whatever we decide to, however we decide to build this, we're going to receive a larger share than if you own only 10 tokens. And so that's the basic idea. Here we are assuming that you have some sort of basic knowledge of how to use Truffle and basic knowledge of like Solidity, so you don't get lost. And Michael or anyone in the Hangout has question, please anytime make sure you interrupt me. The point of this is that everybody learns, and it's good if people have questions so that other people watching the video subsequently can kind of see the explanation and the rationale for certain decisions. So is the objective clear, Michael? Does that sound reasonable?
Yeah, I think that's perfect. And again, just to clarify, we're going to build this off of the Metacoin contract that comes with Truffle. That's the basic token we're using to develop on top of this? Is that what we're doing?
So we're going to take parts of the token contract. Actually, it's kind of there. I should. I'll try to close them so I can. For now, I'll close. This is the one I did. I'll close everything so we can try to start from scratch and make sure that we think and troubleshoot at the same time, so we get good coding skills. So okay, the first thing we want to do is we're gonna want to build our contract and save it somewhere. So the first thing we want to do is, please anytime correct me if I do a mistake that you see. So pragma solidity, and then we're gonna specify the version, which basically is gonna, oops, sorry, my keyboard has a lot of languages. 0.10 or 4. I already forgot. Already you have to open the Metacoin.
I do the same thing. I'm pretty sure it's 0.4.4. I use that one. The only thing I throw out is if you try and use some of the newer ones, like 0.4.9 had breaking changes.
I see.
So yeah, I tend to use some of those 0.4.4-ish up to 0.4.8, and that's where I have most of my experience.
Okay. Well, are you ready to try to venture?
Yeah, let's give it a shot.
All right, so pragma solidity 4.10. Let's do that. So the first thing we're going to do is we're going to build, let me set up the language to Solidity. So I'm using Sublime 3, which has Solidity in it. I'm going to save it. Okay, let's actually, I'm going to build actually first a folder for this. Let's call this make your messy coding. Call it like that. And then we'll go in there. And in there, I'm going to do a truffle init, which is basically going to build all the basic package that are necessary to run Truffle. It's going to make a contract folder and all these things. So now we have contract migration test. So now I'll be able to save this in where is this thing? Messy coding. Do you not see it? Do you see it somewhere?
Your screen is disappearing. I gotta figure out. I think every time I talk, it disappears. So.
Oh, really? Interesting. All right.
I'm gonna mute my mic.
Yeah, that's right. Oh, I see. Okay. So I'm gonna go. Sorry, I'm just organizing my stuff. Messy coding session. No, I'll go in messy coding. Truffle. That was just not in the right directory. All right, now we're gonna save blockchain here, messy coding, Truffle. We're gonna put it in contract, and we're gonna call this dividend token. All right, so now we want to build our contract, which is gonna be dividend. Wow, I can't spell. Dividend token. And this contract, well, good tip, I always do. That's a good habit, I think. A dividend token. Systemics to put comments. It's kind of not that necessary in Solidity. It's sort of a habit I have from other language that are more complex. But it's useful to have comments. So the first thing we're going to do is we're going to build a constructor function. Constructor that basically is a function that's going to be run only once the contract is deployed. And this has to have the exact same name as your contract. So I'll even copy paste just to make sure. And since we're making kind of a even before that, we should few variables. So the first thing we're going to do is we're going to have a mapping, and mapping, how is it done? The mapping, so this thing here on the right side, you're basically, I'm hiding the right side, so I try to cheat at least time as possible. So you're going to do a mapping of addresses, so an address to uint, and I believe that's how you do it. And we're going to call this balances. So balance is going to basically map addresses to uint, or integers values. And
hey, is it worth? Do you mind me interrupting real quick? I just wonder if it's worth doing one of two things here, because I know in Solidity there's I should probably find a document, but there's some known common types that are available. And I know from the sample contracts I wrote, yeah, you use these mapping things a lot, and there's an address type, but the address is just that unique 40-character address that gets created, your Ethereum wallet address. So in this case, we're mapping what is eventually going to be a I guess I like to think of those mapping things as like a scripting dictionary where it's a key value pair, and by giving it that unique key, the address, you can get the balance of it, the uint. But the unsigned int is one of them. There's strings, bool. I can't remember some of the other types, but like there's a fairly limited list. So I didn't know if it was worth. I didn't want to have a whole discussion on it, but I didn't know if that line of code would be confusing to somebody who is looking at Solidity for the first time. That's all.
Right. I think these are really valuable inputs, so feel free, please, to interrupt and add some stuff. It's easy sometimes to forget what you know and what people don't know.
Yep.
So yeah, you have these unsigned integers, so everything is positive, or just raw values. And yeah, so the address, as Michael said, is basically dictionary, like in Python and other stuff, where you put an input, like you index. You're indexing input, so to speak, is an address, and that's going to give you a int that is associated with a given Ethereum address. So, okay, so we have that. We're also going to have a owner. So a owner is going to be the one that basically is going to have all the privileges, and we're going to make a small function later that, or a modifier that's going to basically allow certain functions to be run only by the owner, and the owner is going to be the one that creates the contract. So now we define these two things. We're going to put an initial value. So once we're going to create our token system or balances, we want the owner to have some value initially, just for the sake of having something so it's easier to play with Truffle. So we can put init value, and apparently there's the habit of putting the underscore at the beginning. So when the contract is going to be deployed for the first time, what we're going to do is we're going to set the owner. Owner is going to be equal to message.sender. So msg.sender is the person that's going to initiate the contract, or it's the person that generates or sends a transaction, I believe, to the contract. But in this case, because this is the first time it's going to be run, the message sender has to be the person that creates the contract. The second thing we're going to do is we're going to set the owner balance to 111, this value. So once the contract is going to be created, the owner is already going to have initial token balance of 111. So that's our constructor. Then we can add a bunch of function. And the first one I'll do is owner function. So we can call this is owned. Owner, sorry for my spelling. Owner modifier. So we're going to create a modifier. And this is basically going to allow us to, it's kind of like an if state. It's a nice property of Solidity where you have some if statement that you can kind of plug in functions, so that's fast. You don't have to rewrite all the times the different if statement that you're interested in having. So is own, you're going to have, if this is own, the only thing you pass through, I believe, is require that MSG sender is equal to owner. So basically, this is a modifier that's going to always look for is the person currently sending a transaction or request or calling this contract, is it the owner? And if it's not the owner, it's going to throw, it's basically going to stop the execution. So that's our modifier. And then we can create, yeah, Michael?
Yeah, can I ask a dumb question? Because it's I'm not, I never spent much of my developing career as a JavaScript developer, but is modifier, is that something that's unique to Solidity, or is that something that's available in some of the other languages you've worked with anyway?
Well, I'm 95% sure other languages uses it. I personally am more of a data analyst, so I never used JavaScript or more web-based languages. So Solidity for me is kind of like, I'm more familiar with Solidity now than JavaScript. So I have no way of comparing.
Yeah, like when I was first playing with them in the course I took, like I had like it becomes apparent how you use them, because you use them like as attributes, or that's how I would always term it in C# coding or something like that, because it's like when you later write your functions, that's how you employ the modifier, as I understand it. So when you're writing some function that you're saying send money, or like withdraw money, because like I'm the owner, I want to withdraw some of my money, it's like that's when you'd say only the owner can do this feature. So that's how you'd employ this. So you'd write some function that you only want the owner to do, and you would tag it with that, as I understand it. Is that's how these are used? Is that true?
From my understanding, it's something like this. Maybe more explicitly, what happens, I believe, is that Implicitly, well, actually, let's try to write the other function that's going to be owner only, so we can explain it at the same time. So let's call the function mint. So basically, a function that's going to be able to create tokens.
Perfect.
So we'll set that for an address. So let's call this the source, so where you want to mint, and the amount that you want to mint in an address. And now here we're going to add the is owned modifier, and then we can add returns, and we can put this as a uint, uint, unsigned integer. So what's going to happen, I believe, is that everything you write in the function. So if you write the minting, if you write the minting part, here let's say minting source plus equal amount, right? Oh, let's complete just for the sake of it. Yeah, let's here. All right. So what's going to happen is that having the is own modifier here, when you compile, I believe, and don't quote me on that, but when I compile, I think what it does is that it basically implicitly going to add this piece at the beginning. So you could add a lot of different modifier, and instead of rewriting it every time, it kind of, when you're going to compile it, it's basically going to add this this piece in bytecode on top of as like in the beginning of your function. And so that's my understanding of how these modifier works in Solidity. So yeah, maybe we can start with this. I think we have already something we can test, because it's probably going to have some errors somewhere. At least that would be a good first intuition. So now what we're going to do, I'm just going to use, for those who are not familiar with tmux, it kind of allows you to organize your command lines. I'm going to first run the test RPC. So I'm running everything on my local machine. Last week, me and Michael kind of walked me through how to do it on a virtual instance with the Amazon cloud. But I use Linux, so I'm just going to go with it locally. So I'm going to run first the test RPC, which is like allows you to deploy contracts on your local machine. So it kind of simulates a lot of steps, but you don't have to wait for the contract to be confirmed and everything. And the second thing we're going to need to do here is first, yeah, contract. So in the contracts, dividend token is here, so that's good. Yep. Oh, I thought I heard you.
Oh, sorry. I'll mute my mic.
No, that's fine. So the second thing we're going to do is, now we have in migrations, we have to specify that we want to migrate or like deploy our new contract that you've built. So the migration in Truffle basically allows you to deploy a bunch of things like in a very easy manner, in a sequential manner as well. Yeah, easily. So you first need to define the thing you want to deploy. So deploy code, I'll just actually copy this piece. It's going to be faster. Okay. Then the token. And this is going to be the, basically give the path to your contract that you're interested in loading. And now you're going to also basically deploy, this is where you deploy all your contracts. So you're going to deploy the new dividend, this word is killing me, dividend token contract. So now this should allow Truffle to deploy the dividend contract on its own. So we're going to first try to compile everything. So it's going to compile to all the lists of contract that it has access to in the current contract folder. Oh, It's probably not pragma, right? It seems like. Oh, semicolon.
Get you every time, huh?
Yeah, well, this is like the kind of thing where when you start these kind of like small details, because Python doesn't require that. So
Yeah.
it is spanning multiple lines. Let's see that.
And here's where,
modifiers.
like, I don't know if I made myself clear that I don't know what versions of Solidity you were using. I had problems when I used anything over 0.4.9. So if you're experiencing weird stuff because we're using something over 0.4.10, I think we got our signals mixed. It's like if you're comfortable using an earlier version, or that's what you did earlier today, I would definitely do that, because there were some breaking changes, even in some of the basic stuff about how addresses are assigned and things like that. So.
Oh, really?
Yeah, like I found like none of my contracts worked when I tried to move them to the later version. So I was like, all right, let me walk before I can run.
Yeah, so me, in fact, I think I'm more used to the later version because I started like recently.
Oh, gotcha. Oh, then that's good. Do what you're most familiar with.
Yeah, I just, like I said, I'm trying to hide this so to practice, but I believe you have to add these kind of things so that there's always need to be something that is outputted.
Oh, that's right. Those modifiers. Yeah, I remember that now.
There you go. Now it works. Oh, wait. Warning.
Yeah.
Warning. Okay, it's a warning. Fair enough. Let's ignore the warning. I don't know if that's dangerous. By the way, the contract we're building is absolutely not secure. I do not have any knowledge of how to make secure. I'm not using like secure math libraries and other things, so do not take this as this secure based. Okay, so now that it seems like it compiled properly, let's try to migrate this. Truffle migrate. All right, cool. Seems like it worked. So now we can go in the console. And the console is, I believe it's a JavaScript console, and I do not have much experience. I just kind of played enough with it so I understand the few tricks that are necessary to use Truffle on it. But basically, there's already the web3 package or library that's already in Truffle Console when you load it, which is pretty convenient. So you can do stuff like see all your accounts that are currently accessible or were created by the test RPC here. So this is the accounts that you're using, and by default, test RPC is going to send commands with the first one. So I'm just going to save this as a variable called ACC. And now the second thing we want to do is kind of have easy access to our contract that we deployed. So what we can do is dividend.token.deployed. Here are the options. And this we can refer it. I'm not exactly sure. These are kind of like the weird things in JavaScript I'm not comfortable with, but you can make what are called promises and other things like that. So what I'm doing right now is I'm going to make dividend token deployed. I'm going to make a then function, or then call, or promise, I believe it's called, but I might be wrong, where now this is going to load or save the contract that is the dividend token deployed here. It's going to save it as div token. So basically this is passed as in function as a. Then I'm referring div token as a, and this is basically going to give me the object that I'm interested in, the contract. So my explanation was probably absolutely wrong. Feel free to correct me in the.
No, I think you got it spot on, and I think that the only thing that makes it tough to understand what that promise is doing is because we're using test RPC, and this happens so quickly.
All right.
Normally, when you're doing this against like a real get node or something like that, some of the things take a second, some of the things take 20 seconds, and it's like when you start thinking about what has to happen, and you know that promise is basically saying, hey, I'm expecting you to send something at some point. Like I'm assuming that I'm going to get this response at some time in the future, and I can count on that happening. And that's basically all that's happening there. And it's weird. It doesn't. We'll feel it if you were to set up a real even a private Geth node on your machine. Even then, you'd feel some of these delays that really start to add up. So yeah, pretty much everything's going to be in a promise for the most part.
I see. Okay. Thanks for clarifying. So yeah, now the cool thing is this is our object, and this basically has all the nice, not that nice, but the functions we defined, so we can see, oh, there's no get balance. That would be a useful one, because right now I can't see the balance of any contract. So that should be a priority function, get balance. Let's do that. Address. Let's call this CDR. And this is going to returns. The returns is going to be a uint as well. So now we're going to do return balances ADDR. And this should be good. Now, I believe I have to repeat all the process because, yeah, I have to redeploy, reopen the console. Because last time I tried, if I stayed in the same console while I compiled and redeployed, did it work? So we're going to have to do truffle, migrate again. And you have to put the reset whenever you're trying to re-migrate something. Do I have to compile? I probably have to compile first.
Yeah, I have a feeling.
Yeah, that made some changes to it. Warning and counter, I think it's the same one. Oh, right. It's because the warning is because when I said deployed, I said you should expect an int value. And actually, I kind of forced it, but this should be this, where now you can deploy it with an initial value. So this cool thing, you can basically just add it in this part in your toDeployContract.js, and you can say, now I'm going to initialize it at 113, for example. And now when you're going to deploy, right. So it's because it wasn't using my function, I believe. So the warning should go away. There you go. Okay, now we're gonna migrate again. And the point of doing these kind of structured, messy coding sessions is that someone that goes through the same problem can kind of see how we troubleshoot, and might not be the best troubleshooting, but at least, yeah, it gives you an idea of the kind of error you can run into.
I agree completely. That's been my whole experience with because it's man, there's so many dependencies in all of this. You'll be surprised at some of the fixes you find.
Yeah, completely agree. So okay, I'm gonna redo these little steps. That I'm gonna do this dividend token deployed. All right, so now we have, all right, good. So now what we can do is we can say get balance, and we're going to call it, because this is when you call it, it's going to give you what's expected to be returned by the function, and this function doesn't change anything. So hopefully, yes. So the input we added here, our initial value will initialize our account number 0 with the same amount, whereas the account number, the second account, contains 0 in it currently, which is fine. That's what we expected. So now what we can do, we're just going to test the other function, the mint one. We're going to mint account number 1. So remember, account number 1 had 0 in it. So we're going to mint, for example, let's put a nice number, 100. And hopefully that's going to say now the account balance, yep, so that works. So now you have 100, so the two accounts have 100. So now we kind of have a basic sort of token contract. How can we get some sort of dividend system? And now, Michael, feel free to pitch in ideas. I probably thought a bit more about it because, yeah, I was the one in charge of this session. But there's some, of course, like complex way of you basically count the number of tokens that each addresses has, and you'll have some sort of pool where tokens are sent and then redistributed either at certain frequencies, so every 1,000 block, or whenever the like pool, so to speak, reach a certain value. So you could have a pool that when it gets to 100 ether, 10 ether, then it redistribute these 10 ether proportionally with respect to how many tokens are going to be held. But there's another even simpler way of doing it, which is both elegant and frightening at the same time, in my opinion, but is the idea of burning tokens. So basically, if you have like a finite number of tokens, let's say like 1,000, and each token is worth $1, and if you basically burn 900 of them, then you should expect the last 100 token remaining to be much more valuable, or 10 times more valuable than they originally were, because they're rare. So one kind of sneaky way of having a dividend token like mechanism is basically by burning some of the tokens. So each of the token is now worth more, and the more token you have, the more value the more you benefit from tokens that get burned, because each of your token increases in value.
Hey, before we get too much deeper, can we think through how users would use this? So an owner is going to deploy this, and that's the person that's going to manage the contract. But I'm assuming other participants are going to join in this because they want to be partial shareholders, or whatever term we want to use, but they want to stake in this, and the percentage of their stake is what dictates their dividend. So could you explain a tiny bit of that, because I'm still a little clear of like, okay, this thing gets established. How do people buy into this thing? I guess where do tokens get created? Or you said there's going to be a finite number. Does the owner allocate tokens to people because something happens offline? Or would you mind just like building out our fictitious example a little more with regard to that?
Absolutely. So this, of course, contract is like not like a token cell contract, and that would be actually an interesting one. Try to build a basic token cell contract, where basically the idea would be that this minting function, you could modify it where if you send me 10 ethers, then I'm gonna mint you 100 token or something like that, and this could be only be possible during the token cell, token distribution period, and after that, it's gonna be impossible. So you could have some sort of like if statement requires that required total amount is less than 1,000 ether, for example, and then once it's done, once you do that, you can't mint anymore. So you could have that. So let's say you, Michael, are interested. You would send me a number of ether, and then I'm going to give you I'm going to give you a certain number of token. For example, 1,000 per ether, or 100 per ether, and so that's basically, in this way, you're going to be a shareholder. And we can give an example of like when and why would you burn tokens or like create dividends. So are you familiar with Golem?
I know the name. That's about it. I don't really know what's behind it.
Oh, perfect. That's even better. So Golem basically is some sort of peer-to-peer like platform where you can rent your computer hardware to people that want to run computation. So you can say, hey, during the night, I'm not using my CPU, I'm not using my GPU. You can use it if you pay me. And so someone having Golem tokens, basically, if I have Golem tokens and I want to run some like AI or whatever, like data processing on your computer, what I can do is say, okay, I'm going to send you this this basically script that I want you to run on your computer. And once it's executed, you're basically going to charge me on how long it took and how much resources it took. And I'm going to have to pay you in Golem tokens. And what you could imagine basically in such a system is that every time I use the Golem service, or I pay someone to use Golem, let's say I'm paying you like 1,000 Golem, what's going to happen is a percentage of it is going to be burned, or a fixed amount is going to be burned. So I'm going to send you 1,000 Golem for the computation that you ran on your computer for me, but you're going to receive 999, and there's one token that disappears. So that would be one way of basically every time, the more people use the system, the more valuable each token that remains becomes. And of course, the scary part is what happens if you get to 0, and I think we kind of can skip on the details. It's just like a very simple way of how to make the value increase for shareholders. So if you're a shareholder and you never use your Golem, then none of them are going to be burned. The only thing that's going to happen is you're some sort of guarantee that the value is going to increase as more and more people use the system, because their tokens are being burned every time that there's a transaction. Was that clear?
That helps immensely. Yes, thank you. Yeah, that helps a lot. Thanks.
Great. All right, so now we're gonna have this. Actually, let's make a function that is basically pay or transfer. You can imagine transfer. Let's call it pay. So pay is gonna be address. So the payee, the person that pays. So we're gonna say from, and another address is gonna be to. And this is absolutely not the way you should do it. It should be more complex than that, but let's just do it this way for now. And there's going to be the amount at which you pay the person for the service provided. And for that, the first thing you're going to do, you want like basic checks like, does my address contains enough value to send? So you're going to say balances from. This has to be larger or equal to the amount, right? So you can't send more than you have. And I think for now that's enough requirement. What we can do, so now we're gonna first remove the amount from the address at the from address, so balances from. And we're going to say you're going to subtract this by the amount that you specified. And we're going to increase the value of the person you're sending your tokens to by the same amount. Actually, let's add a very simple way to burn. Let's do amount -1. So every time someone's going to pay someone, there's going to be -1 token. So one token is going to disappear, basically. So it might be more elegant to send the tokens in another address, like 0x00000, and kind of like see how many tokens were burned. But for now, we can just like hack it this way. I have to specify what needs to be returned. So let's returns. That the token was burned. So I'll just try to put some variety here. So you're going to return true. If that worked, then you're going to say there was a payment that was done. And you can also add events in your contract. I'm not too familiar with events yet, but that would be another cool thing to explore in the future. But basically, if you add an event, whenever this function would be executed, you'd have some sort of output to the network that says, hey, this payment was established. I believe, but don't quote me on that. Okay, yeah, so now we have...
You're exactly right. The events are a nice way of logging everything that's happening. And one of the things that isn't inherent at this stage in anybody's, at least anyone probably who's watching this, who's wanting to learn a little bit about Ethereum development, is all this stuff costs gas. And so the more efficiently you can write your function so that it doesn't burn gas. And similarly, if you wanted to set up, the other way to do it is if you wanted to log this, having your own logs that live in a contract, that's what gets expensive. Because if you wanted to log that so-and-so sent this amount to this amount on this date, and it was their current balance went down to another amount, that would cost you a lot of gas to do it in your contract. But the logging's separate. The logging is actually built into what is supported by Ethereum, and it really doesn't cost too much, if that makes sense.
Does it still cost something?
It's like I don't know exactly. I know if it does cost anything, it's fractions of what it costs to do to do state changes like we're doing here.
Right. Okay, that's fair. So if it costs something, that it's optimized so that it doesn't cost too much.
Right.
All right. So does this function sound reasonable to you? Does the burning system adding a -1 or subtracting 1 every time kind of makes sense?
I like it. I think it's really cool. The only thing I'd throw in, like if there were two things that were brought to my attention that were pretty interesting, and one of which is the simple concept of what happens if somebody wants to send 7 tokens. Like, how do you divide that in half, or like like dealing with halves of something? We're not doing that here. But the other thing is, what happens if we call pay, and now in test RPC it happens quickly. But on the blockchain, when you're changing state, it needs to be mined, and that's going to take 20 seconds at a minimum. I think the term of the problem is called re-entrance. So what typically could happen, or what can happen, is I could hit pay, and then immediately right after send the exact same transaction, and it'll double dip those amounts. Because this thing still doesn't know the first in the second transaction, it doesn't know that the first one happened yet, so it still thinks the balances are what they were. And there's ways to guard against that, but I just wanted to throw that out there now because anyone who's watching, it should be in the back of your head anytime you're seeing money change from one person to another. And even though we're doing it somewhat internally, it's just something to be aware of.
Right. So right now you're saying my contract is vulnerable to these kind of things. Is that correct?
I believe so. Like it's like I don't know if the rules apply to sending Ether. Like we're not sending Ether. We're just saying, hey, move this amount from this address to this address. So this isn't Ethereum we're burning. Like this is just our fake whatever token. We're making up. But I think that the general accepted practice for anything like this isn't so much that you change the amounts. It's like you just kind of put them in a place where the user, the recipient of that money, retrieves it rather than it just like happening. And I'm probably not doing a great job of describing the risk and how it happens. But I know in some of the contracts we were working on, it was driven home that it's just like, no, like the easy way to do it is just, and the intuitive way to do it is just like we have on here. But the safer way to do it is don't move the balance here. Let me think through this. I'm going to speak as I'm thinking, which usually doesn't work well. But imagine if we had like a separate mapping, and I'm not suggesting we do this, but imagine we had a second mapping that had withdrawals or pending withdrawals that kept the amount that has been made available for one of those recipients to withdraw. And on the withdrawal, that's the thing that actually finalizes the thing, because I'm not doing a good job of explaining why that solves the problem, but that seemed to be a common coding practice in anything where you're adjusting amounts.
Yeah, I was kind of trying to look at the MetaCoin if they have anything that would look similar to that. The only thing I'm seeing is they use it like a native transfer function, but I don't think that solves the issue.
No, it doesn't. I'll try and see if I can dig something up. Maybe we'll look at it real quick as part of this discussion, or I like keeping this simple. Like in my mind, I think we have like this pretty cool example that matches the context of what we were trying to do, and that's awesome. So
but that would be a really good topic eventually, some sort of common attack vectors that like basic contract run through, and then we could take this code that we just wrote and basically say, okay, this is garbage, we need to add some extra security in there, this one is like possible for this attack, and it'll be nice to work through it. Okay, so for now, let's take our unsafe contract and burn something. So I'm just gonna that would be the first kind of like dividend system, but basically let's redo everything. I'm gonna recompile. All right, now I'm gonna truffle, migrate, reset. We should eventually make a list of suggestion of topics people want to do, and it would be cool to also have like some sort of SE coding session for noobs, which is what we are.
Great.
And like could have like messy coding intermediates. Hopefully that's going to be us in like a few weeks or months. So we can like have more stuff. But it'd also be nice to have like a list of suggestions or like kind of topics we would like to explore.
Agreed. No, I like it.
All right, cool. So okay, now that I did compile and migrate, I'm gonna Truffle Console. We're gonna do this. All right, and then we're gonna token deployed. Yeah, this is one thing that is really useful with Truffle is you can write some test script that are basically are gonna run a bunch of tests that like if I create this contract and I'm expecting it to have an initial balance of this amount, then you can basically make sure that this is the case. So you're going to have like an if statement in your test contract that says, okay, yes, the initial balance was indeed the correct one. You can also have like, okay, now if I'm sending tokens from this one, and you can like predefine all the different kind of things you want to test. Like right now, I'm things where now I want to do a get balance, for example. I don't have to do that every time. You could have like, and I know it's working, it's just paranoia that something didn't work. But you can set this up and make sure that everything works as expected. Right, so that works as expected. The expected value was this. So you can basically write a script that makes sure that everything works as expected. So that's something cool with Truffle and other stuff like other things. You can work tests on other things, but Truffle makes it easy. Apparently, I've never done it. So okay, now we can get balance. This one has 0. This one has 1, 1, 1, 3. So what we can do is we're going to say, all right, now let's say we're simulating. You executed my things on your golem, on the golem network, and I have to pay you now. Now, obviously, you want this to be, the payment system should be like automatic, but in our case, let's just keep it simple. So I'm gonna say I'm gonna pay. So the account, again, maybe that thing shouldn't be from, it should be you. So you shouldn't need to specify this. But let's say someone is paying someone else, and if kind of anybody right now, anybody can pay for anyone else. So yeah, let's leave it this way for now, just for the sake of time. But yeah, that would need to be changed. So account 0 is going to send to account number 1. Let's say 3, right? So this one here should be 1. So let's try that. All right, and now we can verify get balance. All right, 1,110, that's fine. And the other one, 111, 2. So that worked because we see now I sent 3, but effectively 1 disappeared, right? So you could basically repeat the process as many times. You could do a for loops, right? Now I'm being lazy and I'm kind of like spamming it. But now verify, okay, how many did I remove? 144. And there's some amount missing. And every time there's one missing, and you could imagine that eventually you would have very little tokens remaining. And the address number, let's say another address had 1,000, then you could imagine that these two are basically destroying all the tokens remaining. And the third address that didn't spend anyone is going to now contain or have like a significant proportion of the amount of tokens on the network, and then therefore their value is going to increase. So that's kind of like the first simple naive dividend system I could think of that was the easiest to implement. Now
That's really nice.
we could, yeah,
That's a really nice start. Yeah, no, hey, and I hate to do this. I'm probably gonna have to wrap things up in a couple minutes because life is intervening, unfortunately, and I got to pick a kid up. But
that's great.
I think this is a really like nice start to understanding a real simple contract, and nice job on that.
Well, thank you for being there for me and giving me hints and correcting me whenever I messed up.
Oh, I didn't correct much. But yeah, no, it's like what did you have anything else you wanted to cover while?
No, because I mean, other dividend system would be too complex to implement within like 5 minutes, and to make sure they work properly. Because then you need like another way I can just show that I kind of mentioned, but you could have something where like a pool here. Where I'm basing pseudocode right now, where you can have a pool that basically plus add a certain portion of the amount of each transfer. So instead of here having -1, right, you could say you send them amount -1, but you have the pool that is plus equal 1, and then so you don't destroy the actual tokens, you save them in the pool, and then you could have something like if like a pool increase is above 100, then you have like called the distribute function, and then this is basically going to distribute proportionally to the account holders. But like writing this distribute function and this pool and making it like work and nice might take some time. So I think right now I'm happy with leaving things how they are right now. And
I think this is great. We could build on this because like I wouldn't mind building an event structure in here. That'd be awesome. Maybe I'll dust off my notes on reentrance and to see if that even matters. So that I think there's a couple things like I don't know if you want to keep building on this.
Sure.
I kind of like that plan because anybody who's following along at this point should be able to get this contract running locally. And they could play with it on their own, and they can do a little research and see, hey, how do I build an event into this? It's not difficult when you see it done. And then maybe look at truffle tests because if you start testing early, it's really easy to add a new function and build that into your test. If you wait until the end, it probably isn't going to happen. So I think we have any number of ways we can go with this. And I think this was a great start.
Cool. Yeah, I'm excited for the next one. So because I really want to learn all these things, so it's super useful for me to kind of forces me to practice and explore these ideas before live streaming.
Yep. Yeah, you and me both. Hey, would you mind sending me that contract code, and I'll put it in the description of this YouTube video so somebody doesn't have to retype it if they want it to be easy.
When you said that maybe we should iterate on these things, I was thinking of we could make like some sort of GitHub where
that's perfect.
Here's session 52 and week 36 and week 1, and then we can have like all the different contracts and resources for every week.
That's a great idea.
People could like. Cool. All right.
I like it. Hey, well, you and I will talk about some of that stuff offline, and I think this is a great start, and we'll I'm game to keep doing this every week, and I'm with you. Maybe in a month, I'll be able to do something on my own again. Hey, listen, thank you so much for doing this. This one went great.
Yeah, great. Let's keep in touch on the Gitter.
All right.
All right.
All right, cool. Hey, well, I'm gonna wrap this up, and we will again next week.